students. Today we have discussed product of sum reduction using Karnaugh map or K-map. Last class we have discussed SOP reduction using K-map. Today we have solved n number of problems and also assigned the assignment question for you all. Today's class will solve it using a POS, that is product of sum reduction using Karnaugh map, or it is also called a max term reduction using Karnaugh map. So I have already discussed why a map is required in order to simplification of in order to minimize the expression in more simpler way. Use a K-map, or to represent the functional values in the most natural way, you go for K-map. You go for a K-map. Then we have solved in min terms how it is been for 2 input variable, 3 input variable and 4 input variable. Today's class will see for POS, that is product of sum terms, using a K-map. Here you are going to represent n variable. So if you have n variable 2 to the power of n, that is 2 to the power of n squares. I have already told K-map is nothing but is a graphical display of fundamental product in a truth table. Here if you are representing n variable, then 2 to the power of n squares will be present in your K-map. A K-map is nothing but a rectangular box which is divided into number of squares. Each squares represent either min term or max term. Today's class we are solving using max term. So n variables means 2 to the power of n squares will be available. First we will see for 2 input variable. See in your K-map, one important thing, your K-map, you are going to represent, you are going to encircle ones, adjacent ones, that not adjacent ones. Here you are going to encircle your adjacent zeros. Here in your min term, you have encircled ones, that is SOP. In your POS, you are going to encircle zeros, adjacent zeros, and remaining places you are going to place 1. So the output which has zeros from your truth table, you are going to represent that zeros is being encircled in order to form octet, pad or quads. So for first we will see for 2 input variable. Here in 2 input variable the K-map is 2, that is 2 that is nothing but 2 to the power of squares, nothing but 4 squares. 2 to the squares, nothing but 4 squares can be represented. So here 4 squares. This is suppose A, okay, B. Okay. Here my subscript to address value of max term is 0, 1, 2, 3. And here in your max term or product of sum, your 0 stands your uncomplemented, 1 stands for your complemented. That is 0 means it is uncomplemented, as usual the variable. 1 means you are going to take the complemented variable. So here it is x bar, sorry, a bar, b, that is nothing but your b bar, that is your 0, 1, b, 0, b bar is nothing but your 1. So 0 means it is as usual, that is uncomplemented. 1 means you are going to take the complemented variable, that is. So here this is the 1, that is nothing but 2 input variable. So the combination, since it is a product of sum, so you are going to form a sum product, that is sum term, that is a plus b. Here you are going to take a plus b bar. Next here you are going to take a bar plus b. Next a bar plus b bar. This is for your 2 input variable. See, once again I am taking 2 input variable a and b. This 2 means 2 square, that is nothing but 4 squares. 4 squares is represented 1, 2, 3, 4. 4 squares is being represented in your K-map. So here complemented means you are going to take it as bar. Uncomplemented means here you are going to consider as 0. Whereas in the min term, complemented means 0, uncomplemented means 1. It's just quite opposite to your max term. This is for your 2 input. A means 0. A bar is nothing but 1. 0 means, that is 0 means B as it is. B bar, your horizontally it is nothing but 1. This is for your 2 input variable. Let's see for 3 input variable. Okay, in a 3 input variable, that is 2 to the power of 3 is nothing but 8. You are going to divide your K-map into 8. first you address the subscript, that is 0, 1, 2, 3, 4, 5, 6, 7. So here nothing but 0, 1, 0, 0, 0, 1, 1, 1, 1, 0. Again here the rule, it is used here gray code. I have already explained what is gray code. Again you are going to perform in your max term or POS also you are going to perform a gray code. So this is 0, 0, 0, 1, 1, 1, 1, 1, 0 representation is nothing but gray code. That is the gray code are nothing but the binary numbers. In each successive numbers only one place will be changed. Such a thing we call it as 1-bit variation can be changed from a complemented to uncomplemented or vice versa. Such a thing we call it as gray code. For here x 0 means x as it is, 1 means x bar, here y means that is nothing but your y, z as it is, here y, z bar, next here plus, okay, use plus here, y bar, z bar, here y bar plus z. So you have to write the combination for this is, that is nothing but x plus y plus z, here x plus y plus z bar, here x plus y bar plus z bar, here x plus y bar plus z, next for z bar, z x bar plus y plus z, next x plus y plus z bar, next x bar plus y bar plus z bar, next x bar plus y bar plus z. So these are the combination. This is nothing but the combination of 3 input variable. I am considering 3 input variable x, y, z. So first before the partitioning of the squares, now you have to address the subscript value of a max term m0, m1, m2, m3, m4, m5, m6, m7. So this is nothing but addressing or subscripting each max term. Here even this POS also follows the gray code. Gray code is nothing but representation of 0, 0, 0, 1, 1, 1, 1, 0. So since it is sum of product, that is nothing but POS nothing but sum term. So I am using plus sign for each after each digit. After this one adding the sum term, you are going to multiply. Use the AND operation and you are going to multiply. Here 0 stands for your uncomplemented, 1 stands for your complemented. Similarly 0 stands for the uncomplemented and 1 stands for your complemented. So just I have abbreviated this for x and y, z as my 3 input variable. Let's see 4 input variable. So we have seen 3 input variable, 2 input variable. Let's see for 4 input variable. So that is nothing but 2 to power 4 is nothing but 16. 16 possible of square should be represented in your K-map. So first draw your K-map. So that should be divided into 16 squares. So let's take my input as wx, yz. Okay. Here first to address the values, that is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So after addressing, you represent the binary values, that is nothing but 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. So you represent in the form of variables, that is nothing but w plus x, next w plus x bar, w bar plus x bar, w bar plus x, here y plus z, next here y plus z bar, next y bar plus z bar, here y bar plus z. So I have already told you that is nothing but here 0 means it is uncomplemented, 1 means it is complemented. So here also the K-map representation for your 2 input, 3 input, 4 input follows the same as of your SOP. Only the complemented and uncomplemented changes here. The subscripted value also for each square is same. Here you are going to do a product terms. Then you are going to apply a what is that AND operation. You are going to multiply it. So here what's my expression will be w w plus x plus y plus z. Here now here w plus x plus y plus z bar. Here w plus x plus y bar z bar. Here w plus x plus y bar plus z. Here w plus x bar plus y plus z. Here w plus x bar as it is, these two, plus y plus z bar. Next w plus x bar plus y bar plus z bar. Next w plus x bar plus y bar plus z. Next for next term w bar plus x bar plus y plus z. Next w bar plus x bar plus y plus z bar. Next w bar plus x bar plus y bar plus z bar. Next w bar plus x bar plus y bar plus z. Next last thing, that is nothing but w bar plus x plus y plus z. Next w bar plus x plus y plus z bar. Next here w bar plus x plus y bar plus z bar. Next you have w bar plus x plus y bar plus z. So this is nothing but your 4 input variable. So I am using wx and yz is my input variable. For this I have performed your K-map. So similar to your midterm, you are going to represent your K-map in your max term. Let's solve one problem. Then you understand how this particular POS reduction can be done using K-map. Next, we will see how to derive POS, that is product of sum, using K-map. We also discussed summary rules of the SOP using K-map. Same rules, instead of sum like changes will be there in a POS. What is the first step means? Prepare truth table for a given function. If they are given any expression or function, for that you are going to prepare a truth table. After preparing a truth table, then you have to draw an empty K-map for a given function. After preparing the truth table, based on the function, whether it is a 2 variable function, 3 variable function, 4 variable and so on. For that you are going to split the K-map, depends upon the number of squares. After preparing these squares, that is the K-map, then you are going to map the given function by entering zeros. That I have already told you in your max term or POS. You are going to encircle zeros, adjacent zeros, not your 1. 1 it is represented in your min term or SOP. Here you are going to perform a max term, that is only zeros as the output can be considered. So encircling your adjacent zeros. So after encircling the adjacent zeros, then enter the left out squares in a K-map that has been marked as the 1. The left out K-map squares, after entering the zeros, the left out squares, empty squares is marked with 1s. After entering the zeros for your output and left out empty squares is being marked with 1, then you are going to perform an encircle adjacent zeros in the form of, first you are going to form octets, quads and pair. Okay, you are going to first find whether octet is possible, next quad is possible or pair is possible. After finding out your octet or a quad or pair in your given expression or in a given K-map, then if it is you have find any map rolling or overlapping is there, you have to perform a map rolling and overlapping. That is, do not forget to overlap and map rolling. If your expression or a K-map consists of a map rolling, I have already explained what is map rolling. That is your corners, leftmost, rightmost or topmost, bottommost corners or corners of your edges of the squares can be rolled as a map. That is when you fold the paper, it looks like adjacent ones or zeros. That can be map rolled. That is one. What is overlapping means? Same one can be used by more than once. We call it as the overlapping. And we also learn what is redundant groups. Redundant groups is a group that is whose all ones can be used by another group. Such a group we call it as redundant group. These three things we have already studied in your min term using your SOP. Same thing you are going to apply for even for POS. So remove redundant groups if any if you found in your K-map. Then write the reduced expression for the groups and apply the AND function. You are going to apply the AND function for all of the expression what you derived, that is sum term expression can be combined with your AND function. That is nothing but you are applying your AND symbol, dot symbol, and you are going to perform a reduced expression. Let's see, solve a problem, then you understand how can these rules can be applied to that particular function. See here, listen students. So they have given the question, simplify f of function of a comma b comma c that is equals to pi of 0 comma 1 comma 2 comma 6. By seeing the question itself, you can understand it is a max term. If pi if it is any expression which is written in the form of pi means it is nothing but your max term. So the given expression here it is f of a comma b comma c is equals to pi of 0 comma 1 comma 2 comma 6. So by seeing the given expression itself, you can find that it is a max term. If summation is given, this represents your min term, or small m is represented as min term. If they can give us the pi of a capital M, just pi. Understand that is nothing but your max term or product of sum. For this first the rule is nothing but you have to draw a truth table. So what is it? How many number of variables or littles are there? A comma B comma C. So represent A comma B comma C as a input A, B, C. My function value f. So for this 3 input, that is 2 to the power of 3 is nothing but 8 possible ways of representing the variables. So for this is first one is 0 0 0, that is 1 multiples of 2, 1 2 2 2 is a 4. For 0 that is 0 1 2 3 4 5 6 7. So 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 1 1 1. This is my input representation of 3 input. So they given the function that is pi of 0 comma 1 comma 2 comma 6. For 0 you have to represent it as, that is you have to represent 0 here. Next for 1 0, for 2 it is 0, for 6 it is 0. The remaining 1 you place it as 1. So which has the output of zeros, for that I am going to map the k map. So which one now? This particular function 0 1 2. Okay, then your 6. So for this I have to draw a k map. So first we will draw a k map for 3 input. 3 input is nothing but 8 squares. So 8 square I am drawing a k map. 1 2 3. 1 2 3 4. So just divide by half. So when you count 1 2 3 4 5 6 7 8. Just what are the input? A, B, C. So address the subscript, that is nothing but 0 1 2 3 4 5 6 7. So represent in the form of variable, that is nothing but your 0 1 0 0 0 1 1 1 1 0. So represent in the form of literals or variables. 0 means as it is, 1 means A bar. Here 0 means as it is, B plus C. 0 means as it is, 1 means complemented. Here B bar plus C bar. Next here B bar plus C. So after addressing the squares k map, you have to input, that is nothing but you have to enter your zeros for the output which has represented in the form of, for k map of using a max term, you are going to take one here 0 as the output which has the output which has zeros. So here what we have, m0 as 0, so represent with 0. Okay, represent with 0. Next m1 as 0 0. Next you have m2 as 0 0. Next m6 as 0 0. The remaining places you just enter 1. So next you have to perform a encircling the adjacent zeros in your max term. That going to perform your octet, quads and pairs. First you are going to see whether octet is present, 8 ones is present. No 8 ones are, sorry, 8 zeros are present. No 8 zeros are not adjacent to each other. Next you have to see quad, 4 zeros are adjacent. 4 zeros are not adjacent to each other. Here you have 2 pairs, that is 2 zeros are adjacent, that is 1 that is nothing but pair 1. Pair 1 and pair 2. So what are my pair 1 means? A as it is one in a pair, a variable changes. One variable changes from complemented to uncomplemented. So what is here it is means? C bar get cancelled. My variable for pair 1 it is A plus B. Next for pair 2, these two. See for pair 1, my vertical as it is, only my horizontal changes. So C bar changes to C. So here B is as it is A plus B. For pair 2, that is nothing but A bar and these two changes. B bar plus, that is nothing but B bar plus C. A is changed to A bar. A and A bar get cancelled. My value is B bar plus C. So the expression for this POS is A plus B into B bar plus C. Once again explaining. After encircling the adjacent zeros, you find whether octet is present, quads or pair. So there is no octet and quads. We will go for pair. That is pair is nothing but M0, M1. Another pair is M2, M6. So for expression for M0 and M1, A as it is you keep it. Only these two variable changes, that is B plus C bar. C is changed to C bar, C get cancelled. My value is A plus B. For pair 1. For pair 2, that is M2 and M6, that is pair 2, M2 and M6. When you go here your vertical, that is A bar get cancelled. The remaining, the expression horizontally is B bar plus C. When you use an AND, you apply an AND operation or a dot symbol across the sum terms, that is A plus B into B bar plus C. Let's see another problem, then you will find to easily understand. Second problem, f of function of A, B, C, that is equals to pi of 4, 6, 5, 6, 7. There are three inputs. So 2 to the power of 3 is nothing but 8 possible squares should be represented. First we will draw a truth table. A, B, C, function f. 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. People know this representation, multiples of that is nothing but 1, 2, 2s, 1, 2, 4, 0, 1, 2, 3, 4, 5, 6, 7. The function for the output here it is, for 4 it is 0, for 5 it is 0, 6 it is 0, 7 it is 0. The remaining place is 1. The remaining place is 1. So you have to represent the K map which has the output as 0. These four things you have to represent it. So first we will draw K map. So for drawing a K map, I need to represent 8 squares. So 1, 2, 3. Just partition this one. So you have here it is A, B, C. Okay. Now you represent the subscripted values. That is nothing but 0, 1, 2, 3, 4, 5, 6, 7. So you represent the variables A, that is nothing but 0, 1, 0, 0, 0, 1, 1, 1, 1, 0. So 0 is nothing but your A, 1 it is nothing but A bar. Here the B 0 means as it is without complement, B plus C bar, B bar plus C bar, B bar plus C. So after representing your binary values, your gray codes and your variables with or without complement, your subscripted in your, that is nothing addressing of your max terms, then you enters your output which has zeros. My M4, M5, M6, M7. So M4, M5, M6, M7. These has the output as zeros. The remaining places you place them 1. So encircle now. Encircle the adjacent zeros whether it forms quads and pairs. First we will see for octet, there is no adjacent zeros of 8. Now when you see for quads, yes, there are adjacent zeros of 4, that is quads. So only one quad is available. So what is my expression for quad means? See, these variable changes, this 2 in a quad, 2 variable changes. So here in the 2 variable changes from a complemented to uncomplemented, from uncomplemented to complemented. Then two variables can be removed. So b plus b bar, b plus c bar, b bar plus c bar, b bar plus c. See, when you see this c bar get cancelled. This b bar get cancelled. B bar cancelled. This c bar get cancelled. The remaining left out it is a bar. Okay. Here you can represent in your question papers of sometimes they represent like a bar or a dash of. This similar to your complement. Don't get confused. A bar, a placed a bar or a dash, that is like 1. It is nothing but that is your complemented. So this quad 1, that is only one quad. What is my expression is a bar. Let's see another problem. Then you will understand much more clearly. Your third example problem or third expression using your sum of that is nothing but your product of sum, that is your max term using a K map, that is nothing but f of a comma b comma c, that is equals to pi of n 0 comma 1 comma 3 comma 4. First you have to represent what is your truth table. So first you represent the truth table. A, B, C. You have a function f 0 0 0 0 0 1 0 1 0 0 0 1 1 1 0 0 1 0 1 1 1 0 1 1 1. This is the 2's multiple 0 1 2 3 4 5 6 7. Now function for which it has a output as 0 is nothing but for 0 it has 0. Next for 1. Next for 3. Next for 4. The remaining places we place it as 0 1 0. See the output which has for the variable, that is m0 is 0. For 1 it is 0. For 3 it is 0. For 4 it is 0. The remaining place we place it as 1. M5, M6, M7. So you have to draw a K map which has the output as 0 for this expression, for this particular thing, and 4 and 5. For this thing I have to draw a K map. So just draw a K map. Just draw a K map that has 8 squares because it has a 3 input. That is input is here, it is A, B, C, and you address the subscripts, that is 0, 1, 2, 3, 4, 5, 6, 7. Now here it is 0, 1, 0, 0, 0, 1, 1, 1, 1, 0. So that should be represented in the form of literals, that is with complement or without complement. A bar, here B plus C, B plus C bar, B bar plus C bar, B bar plus C. Okay. Now you represent which has the output as 0. Here 0 m0 as the value of 0. So it has been represented as a 0. Next 0. Next you have 1, 0. Next which one? M3, 0. Next M4, 0. The remaining places you put 1. 1, 1, 1. See, once again I am telling 0, M0 has 0, 0. M1 has 0, 0. M3 has 0, 0. M4 has a 0, 0. So 0, 1, 3, 4. Now first you find out your octets. Whether octets of zeros are present. No, octet of 0 is not present. Then you go for quad. Yes, quad is there, but it is not adjacent to each other. Then you just perform a pairing. So I can pair my one pair, my second pair, and my third pair. So 3 pairs here. This is my one pair. Okay, this is my second pair, and this is my third pair. So 3 pairs can be done. First pair, that is I write it here. First pair, pair 1, that is M0, M4. Second pair M0, M1. Okay, M1. Third pair, pair 3, M1, M3. So first we'll see the what's the expression for pair 1, pair 2, pair 3. For pair 1, what it is? Nothing but M0, M4. So here in pair a variable, one variable changes from complemented to uncomplemented. So for pair 1, these two M0 and M1, A and A bar gets changes. The left out expression is B plus C for pair 1. For pair 2, here for pair 2 that is nothing but M0, M1. So A remains as it is. B plus C bar get changes. C bar get changes. A plus B for pair 2. Next for pair 3 that is nothing but M1, M3. So A remains as it is. Only my BC gets changed. So B plus C bar, B gets cancelled. So A plus C bar. So after finding out the pairs and doing the expression, you have to see whether it can be overlap or what is map rolling is there. There is no map rolling and overlap. So here one thing is being overlapped, but other expression needs that overlapping. And you have to see if any redundant group is exists. In this case, M that is pair 2 has a redundant group. See here, this this 0 is being used by that is one group. The pair 1 is being used by pair 2 is being used by pair 1 as well as pair 3. So I am removing the redundant groups. If there is any map rolling overlap is there, you have to perform a map rolling overlap where it is being overlapped. Even here it is being overlapped. But you have to see if there is any redundant group is existing. If redundant group is existing, remove that redundant groups. So my pair 2 is a redundant. Removing the redundant groups, that is nothing but my pair 2. So I am removing the pair 2 expression A plus B. My pair 2 expression is nothing but this 2 B. So I am removing the expression A plus B. The simplified expression is B plus C into A plus C bar. Once again I am explaining. After finding out the mapping the zeros, adjacent zeros, straight away by seeing itself you can see whether there is a redundant groups and just remove out. Or you do a pair 1 expression, pair 2 expression, pair 3 expression. Here pair 2, this is pair 1, pair 2, pair 3. Pair 2 is nothing but my redundant group. That is redundant groups of all zeros is being used by another groups. See, this 0 is used by pair 3, this 0 is used by pair 1 as well as the pair 3. Then I am removing this. Straight away I am removing, no need of finding the expression A plus B. You can find only for the expression pair 1 and pair 3. In spite, even if you find for the expression pair 2, then if you remove also no problem. So I am finding the expression for the even redundant groups. Finally, I am removing the redundant expression, that is nothing but A plus B. Then my final expression is B plus C into A plus C bar. So next we will see for 4 input variables using max term in your K-map. So your fourth problem, that is nothing for function, that is y of y comma b comma c comma d is equal to pi of, that is your max term, 0 comma 1 comma 3 comma 5 comma 6 comma 7 comma 10 comma 14 comma 15. For this you have to find out, first you have to draw a truth table. From the truth table you have to mention the zeros output present, that is represented in 0, 1 comma 3. Place the zeros in your output value. Then you draw a K-map. First we draw what's that 4 input truth table, that is A, B, C, D. So I will draw a 4 input truth table, that is A, B, C, D. Next my function is y, here it is. So y. So I am going to represent it in the form of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So here it is multiples of 2, 1, 2, 4, 8. Since it is 4 0 0 0 0 1 0 0 0 1 0 0 0 1 1 0 1 0 0. Okay, 0 1 0 1 0 1. What is it? 0 1 1 0. Next 7 0 1 1 1 8 1 0 0 0 9 1 0 0 0 1 10 1 0 1 0 11 1 0 1 1 12 1 1 0 0 13 1 1 0 1 14 1 1 1 0 15 1 1 1 1. After representing a truth table, for this you are going to represent a K-map. So it is nothing but 2 to the power of 4. It's nothing but 16 squares should be represented. I have to draw a K-map. Okay, here. Now to represent your variable, that is nothing but AB, y of function, that is AB, CB. Here you will subscript the values 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. After writing, write the binary values. That is nothing but 0 0 0 1 1 1 1 0 0 0 0 1 1 1 1 0. You represent your variable. That is nothing but a plus b, a plus b bar. Next here a bar plus b bar. Next a bar plus b. Okay. Here c plus d bar. Here 0 is considered as uncomplemented. C bar plus D bar, C bar plus D. So for the input, that is you have to first represent the function y. So here function y, here it is. So here you are going to represent for function y. It is nothing but what it considers is nothing but for 0. For 0 it has m0, it has 0. 1 it has 0. For 3 it has 0. For 5 it has 0. For 6 it has 0, 7 you have, next you have for 10, then for 14, next for 15. The remainings are ones. For this you have to sketch or you are going to mark the zeros in your squares, particular maximum square. For 0 it is m0, it is 0. Okay. For 1 it is 0. Next for 3 it is 0. Next for 5 it is 0. Next for 6 it is 0. Next it is for 7 it is 0. Next you go for 10 it is 0. 14 it is 0. 15 it is 0. So we have marked the maximum of M0, M1, M3, M5, M6, M7, M10, M14, 15. Check it. 0, 1, 3, 5, 6, 7, 10, 14, 15. Now we just find out whether octets present, that is adjacent zeros are octets, quads and pairs. There are 8 zeros but it's not adjacent to each other to encircle zeros. Then you go for quads. So there are how many number of quads means you have one pair of quad, then another pair of quad. Okay, quads are left. These ones are left. That is being paired. That being paired with this particular M0, M1 and another one M14, M10. So there are 2 quads and 2 pairs. That is pair 1, pair 2, quad 1, quad 2. So there are 2 pairs and 2 quads. First we will solve for pair 1 and pair 2, quad 1, quad 2. For pair 1, take this one, vertically what you have, A plus B. In pair, a variable changes. Only one variable changes, that is from complemented to uncomplemented, vice versa. You are going to remove only one variable at a time. So here, A plus B remains same. Here, C plus D bar. So this D bar gets cancelled. Your expression is left out is A plus B plus C. For this pair nothing but n0 into n1. Got it? So for n0, n1, so the remaining place you place it as 1. So remaining places you place it as 1. You are going to, in a max term, you are going to mark encircle only adjacent zeros. So here pair 1 it is m0, m1, that is vertically is a plus b and horizontally is c plus d bar. So d bar gets changed from one place to another place. So the left out expression is a plus b plus c. So pair 1 is being solved. Next for pair 2. What's my pair 2 here? It is n14 into n10. So here these two. So here a bar plus b bar, a bar plus b. So b bar, b gets cancelled, a bar. So here a bar and your horizontally your c bar plus d as it is, c bar plus d as it is. So pair 2 is being solved, a bar plus c bar plus d. Now we'll go for quad 1. Let me consider this as my quad 1. This is my quad 1. For quad 1, what are the expression here? It is n1 into n3 into n5 into n7. This is my expression. So for this, you consider these two, a plus b bar. So here c plus, in a quad 2 variable changes, c plus d bar plus d bar, these two. So a plus b bar, b bar get cancelled. So the left out is here and here in a vertical it is a plus. Here in these two horizontally c plus d bar plus d bar. So c get cancelled. Left out is d bar. Got it? D bar. So quad 1 has been solved. Next we go for quad 2. My quad 2 is this one. What's my expression here? It is n7 into n6 into n15 into n14. So for this expression, when you see vertically, that is a plus b bar plus b bar. So a bar get cancelled, the left out it is b bar. So when you move to your horizontally, c bar plus d. So d get cancelled, the left out is c bar. So after taking the quads and pairs separately, add all the expression and apply your and function. That is nothing but your and operation. What's my pair here? It is a plus b plus c into a bar plus c bar plus d into a plus d bar into d bar plus c bar. So this is my product of sum or max term using, I have solved my max term using your K-map in a place of 4 input variables. Let's see another problem, then we will come to know what is the K-map using your Karnoff map, that is nothing but using your max term. The fifth expression, that is example, f of a comma b comma c comma d is equals to pi of n, that is a max term, 0 comma 2 comma 3 comma 5 comma 7 8 12 13. So first we prepare the truth table. You people all have already solved how to prepare the truth table. Directly we go to a K-map. It is a 4 input. So 2 to the power of 4 is nothing but 16 squares should be represented in a K-map. First we will draw 16 square. 16 squares. So here the input are A, B, C, D. And first we subscript it 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Then you represent your grey codes 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. Then you represent your expression in the form of sum terms a plus b bar, a bar plus b bar, a bar plus b. Here c plus d bar, c bar plus d bar, c bar plus d. Next one, which has the output as zeros as we mentioned. So m0, m2, m3, 13. I have already subscript represent the each square represents the min term or max term. Here it is max term. So zeros has been placed. For M0, 0. For M2, 0. For M3, 0. For M5, it is 0. For M7, it is 0. For M8, it is 0. Next for M12, it is 0. Next you have M13, you have a 0. So these are the zeros, that is output which is represented for this expression. The remaining places will represent it as 1. So for this you have to find the octets, squads and pairs. So you have to represent octets, squads and pairs. So there is that is nothing but A0, but it is not adjacent to each other. Then you go for quad. The quad 4 zeros are not adjacent to each other. Then you are going to go for pair. So here one pair is being formed. So here another pair is being formed, and here the othermost pairs can be formed. See here, you can pair even these two, but this one is left out. Again you are going to pair. You are going to have a redundant groups. In order to avoid that redundant groups, see here these two can be paired. Again these two can be paired. So this is being used by another term. So in order to avoid that redundant groups, I am pairing separately pair 1, pair 2, pair 3. And these opposite edges of the square, I am map rolling. I am rolling the map. These two will perform one pair. So how many pairs are there? It means 1, 2, 3, 4 pairs are there. So first pair, we go for pair 1, pair 2, pair 3, pair 4. So my first pair will be M0, M8. Next, after solving this one, pair 2 is M12, M13. Next, M5, M7. Next is M3, M2. So for this we will write the expression. First pair, that is nothing, I am map rolling. The opposite is the topmost and the cornermost edges of your K-map can be map rolled. So M0, M8. So here the vertically what you have, A plus B, A bar plus B, the C plus D remains constant. So in a pair only one variable change from complemented to uncomplemented or vice versa. So C plus D remains same, A plus B, A bar plus B. A get cancelled. What's my expression for this is B plus C plus D. For pair 1 my expression is B plus C plus D. Next for pair 2, that is 12 and 13. So A bar plus B bar remains same. Only C plus D, C and D going to change. So here C plus D bar. So D bar get cancelled. That is being changed. Same variable I'm taking. A bar, that is A bar plus B bar plus D. My second expression, that is for pair 2, is being solved. After solving my pair 2, what's my left over? My pair 3 is nothing but my M5 and M7. So I am going to take this one M5, maximum of M5 and M7. So A plus B, this remains same. A plus B bar remains same. Only these two gets cancelled. That is your C and C bar get cancelled. The remaining left out is D bar. Next, pair 4. That is your M3 and M2. So here M3 and M2, A plus B is same. Okay. Only this C and D gets changes, complemented to uncomplemented. So C, D bar and D gets cancelled. The left out is C bar. From this expression, what you got means, so the complete expression is A bar plus B bar plus C into A plus B bar plus D bar into 1, 2, 3. Next what you have? First you have, that is nothing but B plus C plus D into what you have? A plus B plus C bar. This is my expression given for your K-map using this particular problem. That is nothing but your max term. Once again I am telling, you got the expression for pair 1, pair 2, pair 3. You are going to combine that expression, add that expression using an AND operation or that is nothing but logical AND operation, that is dot symbol. That is sum term, these are called as the sum terms, is being combined with your product. So next I will give you assignment questions. Next I am going to give you all assignment questions. Students, this is the assignment questions under the product of sum reduction using Karnaugh map or POS using K-map, or in other term max term. You are using a max term, you are going to simplify the max term using the K-map. I have given you I have solved you nearly 5 to 6 questions. So 3 questions I am providing for the assignment. That is, I just read out the question. Function of a, b, c, d equal to pi of, pi represents your max term, 0, 2, 3, 6, 7, 8, 15. One question. Second question, function of w, x, y, z, that is equals to pi of m, capital M. Listen here, it is capital M, it represents your max term. If without m also, don't get confused. Either they provide you a pi or summation. If it is a pi, go for max term. If it is a summation, you go for min term. So 0, 2, 3, 4, 6, 7, 8, 10, 12, 14. Your third question, f of a, b, c, d, that is for everything I have given 4 input variables. Solve it. Pi of n, 4, 5, 6, 7, 8, 12. So in this problem, using the K-map, you find out the, first if you are feeling very difficult, draw the truth table and you draw a K-map for 4 input, it is 16 squares, map it. If there is any overlap of map rolling or any redundant groups, if it is a redundant groups, remove that redundant groups, solve the problem. Next, today's class, this ends the Boolean algebra chapter. I wind up this particular chapter. If you find any part of the topic is very difficult, put it in my assignment question. I try to solve all the topics. Next, we'll see in a new chapter. Thank you one and all.